The first thing from this section is something called the horizontal line test. And so we did the vertical line test a couple of videos ago. So this is pretty much the same thing, but just, opposite. Horizontal line test. So for example, let's draw two equations. Here's or two graphs. Here's one graph. Oops. Then here's another graph. So the horizontal line test is, we just keep drawing horizontal lines and we want it to only touch the graph in one spot. So here it touches in one spot, but you see on this graph right here, if we draw this horizontal line, it touches this graph in 3 places. So this one's going to fail the horizontal line test. All right, and this one right here, so here's our graph. If you see every time we draw a horizontal line, it only touches this graph in one spot. So this one passes the horizontal line test. And so the reason why we want to know why we want to do the horizontal line test is something called an inverse function. So if we have an equation, so sometimes the inverse function, we'll explain in a second what this means, but just for now, this function may exist or it may not exist. And so say if we're given an f of x and we have the graph of it. So if we pass the horizontal line test, then we're going to be able to find an inverse. And if we fail the horizontal line test, we're not going to be able to find the inverse. So let's write this down. So if f of x, so we have two options. So if it passes the horizontal line test, this implies it has an inverse. And if it fails the horizontal line test, this means no inverse. So if you ever have a question that just gives you a graph and says, does an inverse exist for this graph? You just do the horizontal line test. If it passes, then we have an inverse, and if it fails, we don't have an inverse. Okay, so let's go on to just explaining what is an inverse function. What does that mean? So we've just been dealing with functions. So for example, f of x is equal to x plus 2. Just a very basic one. So what the inverse does, so normally in general we have something like this, f of x is equal to y. So we're able to plug in an x value and then we get a y value. But let's say if someone just gives you a y value, we want to know, okay, what's the x value we can plug into our function that gives us that y value? And that's what the inverse function does. So what the inverse function does, it works backwards. Instead of plugging in an x to get a y, so we have our x and this is going to be equal to the f, and this is the symbol we write. So let's write off to the side. So this little f inverse, this means inverse of f. So that's just the way we write it, f to a power of minus 1. So again, say if in this example right here, this is a basic one. So like f of 2 is equal to 2 plus 2, which is equal to 4. So we have that f of 2 is equal to 4. But let's say if we knew what the inverse was of this one. So this would tell us that the 2 is equal to f inverse of 4. So if we were able to find the f inverse function and we plugged in 4, we would get 2. Again, meaning that that number that we're finding here, this is the number that you plug into the regular function to get this output. So in order to get an output of 4, we need to plug in 2 to our original equation. So that's what this is saying. So you see here, we plug in 2, we get 4. So in order to get 4, you would have to plug in 2. And so there's going to be ways, sort of one way in particular in finding the inverse. So let's write them off to the side and let's figure out how to find it just for this function right here. So the steps for finding f inverse of x. So the first thing that we're going to do is so we're given a problem. It's usually just, fx equals x plus 2, find the inverse. So the first thing we're going to want to do is replace f of x with the letter y. just meaning if we see an f of x, instead of writing f of x, let's just write a y. So this is going to be the first step. The second step is if we see an x, replace it with, if we see a y, replace it with an x, and if we see an x and replace it with a y. So just switch the x's and y's. And then the third step is going to be solve for y. And then this y we solve for, that's going to be the inverse. So let's take this example up here. F of x is equal to x plus 2. And let's find the inverse of this one. So the first step says replace f of x with the letter y. Okay, so here's an f of x. Instead of writing that, let's put the letter y. Y is equal to x plus 2. The next step says switch the x's and the y's. So here's a y, I'm going to put an x here. Here's an x, I'm going to put a y here. And the third step says solve for y. Okay, so solving for y here, all I have to do is subtract this 2 over. So x minus 2 is equal to y. And then this y right here, this is going to be f inverse of x. So this tells us we found that y is x minus 2. So f inverse of x is x minus 2. And then if you go back up to this problem then, see if we were going to plug in 4, well here's f inverse. If we plug in 4, we get 4 minus 2, which is 2. Okay, so these right here are going to be the steps in order to figure out what the inverse is. So let's do a couple more examples of finding inverses. So this next one, what we have, let's do f of x is equal to 3x plus 1 over x minus 2. And then we want to find f inverse of x. So remember the steps from the previous page, the first thing we have to do is replace the f of x with a y. So we're going to have y is equal to 3x plus 1 over x minus 2. So that was step 1. Step 2 is switch the x's and the y's around. So we have a y here, let's put an x. We have an x here, let's put a y. We have an x here, let's put a y. Okay, so now the third step is solve for y. So whenever we're solving for any type of variable and there's fractions that involve the variable, it's always very useful to get rid of the fractions. So an easy way is to get rid of the fractions here. Let's just multiply this y minus 2 onto both sides. So let's multiply the y minus 2 on the right, and let's multiply this y minus 2 on the left. So if you notice on the right-hand side, then this y minus 2 is going to cancel with this y minus 2. So on the right-hand side, we're just going to be left with this 3y plus 1. Now on the left, we're going to have this y minus 2 times x. So that's going to be xy minus 2x. So from distributing this x across, this x can get multiplied to the y, and this x can get multiplied by the 2. Okay, so now remember, we're solving for y here. And whenever we're solving for a variable, we want to get that variable on one side and everything else on the other side. So the first thing we can do is take this 3y and move it over to the left. We want to get the y's on the same side. So let's start by putting the y's on the same side. So we're going to have xy minus 3y minus 2x is equal to, these cancel, and so we just have a 1. Okay, so now the y's are on the same side, but they're not alone. So in order to get these y's alone, well, let's move this 2x over to the other side. Okay, so now it's almost like what we want. We have the y's on the same side, but they're still not alone. But what we can do here is notice that there's a y in this piece and a y in this piece, so we can factor out a y. So we're going to have y, x minus 3 is equal to 1 plus 2x. And now the last thing we need to do to get y alone, well, we see here we have y times something is equal to that. We can just divide by this piece over to the right. So divide by x minus 3, divide by x minus 3. So then we're going to get y, so these cancel, so we're going to get y is equal to 1 plus 2x over x minus 3. And that's our inverse, so our f inverse of x is equal to 1 plus 2x over x minus 3. Okay, so one way that we can check our work to see if we're okay is something called the inverse function property. So what the inverse function property says is that if we have two functions, so in this situation, let's say f of x is this, f inverse of x is this. So these two functions are going to be inverses only if this property happens. So say we have two functions f and g. So we can say f is the inverse of g. So this is the same thing. But this little, so in math, this just means like this is the same thing. So this statement is the same thing as this statement. F composed with g of x is equal to x. So say if we have a function f and we have a function g, and we don't necessarily know that they're inverses of each other, but maybe we think they are. If we did f composed with g of x and we get x, that does mean that f is the inverse of g. So in this situation, instead of writing g, we could write f with this little symbol on it instead. So let's do an example of this. So our f of x 1 over 2 plus x, or sorry, 2x plus 1, and g of x equals 1 minus x over 2x, inverses of each other. Okay, so so we will say we want to use the inverse function property to solve this. So are these two things inverse of each other? Well, this is just telling us, let's find this, f composed with g of x. And if it equals x, then that means they are inverses of each other. So let's find that. If we are going to find f composed with g of x, that just equals f. We plug g of x on the inside. So here's f of x, we're plugging g of x inside of it. So we're going to have 1 divided by 2 times g of x plus 1. Okay, so let's keep simplifying. Here's g of x, 1 minus x over 2x. So this is going to be 1 over 2. So g of x is this piece, 1 minus x over 2x. And we still have our plus 1. So notice here we have a 2 on the top and a 2 on the bottom. So these 2's can cancel each other out. So what we have is 1 over 1 minus x over x plus 1. So we have to keep simplifying this. So on this bottom here, we're going to need to get a common denominator and combine everything to see if we end up getting this property. So how can we combine this fraction with 1? Well, remember this 1 is just like 1 divided by 1. So if there's an x on the bottom of this one, we're going to have to put an x on the bottom of this one. So an x on the bottom and an x on the top. So we're going to get 1 over 1 minus x over x plus, and then this is going to be x over x. And here we can combine these fractions. So this is going to be 1 over, so these x's are going to cancel. So we're going to have 1 over x. So here we have the same denominator, an x and an x. So we can combine these tops. We're going to have 1 minus x plus x. So that's just going to be 1. So we're going to have 1 divided by 1 over x. And so here we have a fraction divided by a fraction. So this is going to equal, so we can take this top fraction, which is just 1, times the bottom fraction turned upside down, x over 1, and that's equal to x. So you see here that we ended up finding that this f composed of g of x, it ends up equaling x. So this tells us that f and g are inverses.